Welcome back. Let's do one more example right here for section 9.4. This one is a distance, rate, time kind of problem. And we're told in this problem that the rate of a jet in calm air is 225 miles per hour. We say flying with the wind, the jet can fly 1,000 miles in 1 hour less time than it is required for it to make the return trip of 1,000 miles. So let's find the rate of the wind. Interesting. Okay, so what's got to happen right here is that we first have to identify a variable. So I'm going to go ahead and identify my variable based on the question. Let's call that rate of the wind W. Seems to make sense. All right, so what could we say about that rate of the wind W? Well, whatever the rate of the jet is, if we're flying with the wind, that means that we can add the rate of the wind to the rate of the plane to get our total speed of the jet. And so in this case, that would be 225 miles per hour plus W miles per hour to get our speed with the wind. And how about against? Well, if we're going against the wind, we have to subtract the rate of the wind speed from the rate of the plane. Again, we're only assuming that the plane is flying directly into the wind or directly against the wind to make this problem work. So 225 minus W miles per hour. Okay, now this is one of those kind of problems that we might benefit from using a table, and we can set it up in a way that, like we did in a previous set of examples from a previous chapter, we can take the distance, divide it by the rate to get the time required, right? Because once we know something about that time, we can set up our equation in order to make this all work out. So let's see what we can do right here. If our time can be figured out, we know that there's a difference of 1 hour in the time for the return trip than it is for the trip along that 1,000 miles an hour. So let's set this up. We've got our two pieces of our trip. We've got a trip that goes with the wind and one that goes against. So what could we say? Well, the distance for both of them is 1,000 miles. We've been told that flying at 1,000 miles in 1 hour less time is required to make the return trip of 1,000 miles. So we're saying the trip to and the trip back is exactly 1,000 miles. What about our rates? Well, we already have established what the rates are. We know that the plane will be going 225 plus W miles per hour when he's flying with the wind at 225 miles, 225 minus W miles per hour and traveling against the wind. So what can we know about the time? You always just simply go and divide or multiply across to get whatever the time is. So in this case, it will be 1,000 divided by 225 plus W for our trip with the wind, and it will be 1,000 divided by 225 minus W as our trip against the wind. All right, so these are our times, and this is the time with the wind, and this is the time against. What do we know about these two times, time 1 and time 2? Well, we do know that in these trips, if we take the time with the wind, that's T1, and we subtract 1 hour, we add 1 hour, we're going to get the time going against the wind. And again, think about it this way. Whatever amount of time that we had traveling against the wind, or flying with the wind, it's 1 hour less than the time required to make the return trip. Now, if we take that literally, we could have also said that T1 is equal to T2 minus 1. Both are equivalent statements right here. So let's fill in with what we know. T1, well, that is 1,000 divided by 225 plus W. And T2 is 1,000 divided by 225 minus W. And we subtract 1 from that second quantity because that's our trip against the wind. And we're taking 1 hour off that time to get the trip with the wind. Okay, so this is a rational equation we would be multiplying through by our LCD to clear the fraction, and that is 225 plus W times 225 minus W. As our width. So let's multiply through 225 plus W times 225 minus W. I'm going to put that over 1 so that I see it, times 1,000 divided by 225 plus W will equal, we're going to take 225 plus W times 225 minus W, put that all over 1, times our quantity, 1,000 over 225 minus W minus 1. How does that look? Well, the 225 plus W's cancel on the left, so we're going to have 1,000 times 225 minus W, and that will be equal to, when we multiply 225 plus W and 225 minus W times 1,000 over 225 minus W, that gives me 1,000 times 225 plus W. Then I take this quantity and distribute it to the 1 following our subtraction sign, so it's minus the product, 225 plus W times 225 minus W. Okay, this is going to take a little bit of work to figure it out, but I think that we can get it without too much trouble, I believe. So we're going to take this and multiply it out. Let's see, I'm going to have 225,000 minus 1,000 W will equal 225,000 plus 1,000 W minus, and in this case, if I multiply 225 plus W and 225 minus W, I'm going to get the quantity 50,625, the square of 225, minus W squared. Interesting. Okay, so let's work through what's going to happen right here. Let's see. I know that if I subtracted 225,000 from both sides, that term would cancel. So in fact, we're left with negative 1,000 W equals positive 1,000. That should be a 1,000 W. There we go. Minus 50,625 plus W squared. Since it is a quadratic, we want to go ahead and put this equal to 0, so we're going to actually get W squared. If we add 1,000 to both sides, it'll be plus 2,000 W minus 50,625 equal to 0. What is the best way to do this? Well, if you're interested in trying to find factors, I'm sure that we probably can find some factors, but it looks to me as though this is the kind of equation that would be very useful to be solved by completing the square. Because I already know what my square root of 50,625 is, but let's work this through. W squared plus 2000W is equal to 50,625. We're going to take half of 2,000 and square that. Well, we know half of 2,000 is 1,000, and 1,000 squared is just simply going to double the number of zeros that we get from this thing. Of course, that 1,000 is added to both sides equally, not subtracted. So I'll just make sure I'm writing that correctly right here. 1,000 squared is 1,000,000 because it's a 1 followed by 6 zeros. But on the left-hand side, when we had our 2,000 added to both sides, we get W plus 1,000 squared. And on the right, if we work this out, 1,000,000 plus 50,625 is 1,050,625. So in order to isolate W, we're going to take the square root of both sides. So W plus 1,000 will equal to positive or negative the square root of 1,050,625. I found when I took my square root that that is actually equal to 325. Make sure on my calculator that I'm reading that correctly. Let me pause there. And of course, it's not 325, which is a slightly too small, at least in this particular application. That number should have been written as 1,025. So in order to solve this equation, we're going to have to isolate W by subtracting 1,000 from both sides. So we would say W would equal either to negative 1,000 plus 1,025, or W would equal negative 1,000 minus 1,025. That means that the wind speed is either equal to positive 25, which is 25 miles per hour, or negative 2,025 miles per hour. Since we're not going to be taking wind in a negative direction, sucking us in the opposite direction of our 225 mile per hour plane, we'll probably go with the one that makes a little bit more sense right here and say that the wind speed must be 25 miles per hour. And that's the answer we were looking for. Okay, that's it. Good luck with your assignment.